Great. So what we'll actually do in exercise 2 is to look at the impact of changing the separator conditions for a given reservoir fluid. And what we have to do then, as mentioned in the email, the first thing is to create just a fluid at GUR of 1,000 and give it an API gravity of 35. So just so you can compare the results to the answers that I'll release next week. But you'll see, and you can probably do that on your own as well, see the exact same results happening no matter what type of fluid system you're actually dealing with. So this is just to convey the key points. But the first thing you need to do is to go in and create this fluid. Because we're actually going to look at the same fluid, so the same composition, and then we're going to generate black oil tables actually for different surface conditions, but the reservoir fluid is the same. We need to actually be able to store this reservoir fluid. And how we'll actually and use that to make sure that we do this correctly. So I'll just do that real quick right here. The way to copy the predicted fluid composition that we have been that this methodology has predicted would be just to copy the initial reservoir fluid composition. Then you open an Excel sheet, or it could be a text file for that matter, and you just paste it in right here. So now we've stored this fluid composition right here. That we would like to be the same. So we open the reservoir fluid composition yet again, and we just change the method to be a full composition method. And then we simply paste exactly what you have in Excel. So you just copy, paste, copy, and then paste. This works exactly as an Excel sheet. Click normalize to make sure it adds up to 100, and then you simply click save. What this ensures is that we use the same fluid composition, and then we like to, for this fluid composition, for a different set of surface processes, how will the black oil PVT properties change? Okay, and that's the exercise. What you see here is that even though we changed the method, since the composition is exactly the same, the phase envelope is exactly the same as you see here as well. So that's a nice QC just to make sure that you've done it correctly. But over to the exercise. The exercise gives you 3 different surface processes that you're going to change and generate a black oil table with. So we need actually to change over to this tab to the left here called black oil table. Okay, and we'll do that in a second. The first thing, however, that I like to do is just to convey, when we talk about different surface processes in the context of PVT, typically we talk about the number of separator stages, okay? So if you click this button up to the right here, the edit surface process, you actually get your name and the associated process for that. And one of the surface processes that you'll see is one of the sensitivities is already given right here. So you already have one of the answers, okay? And the way to add a stage or remove a stage is simply just to do a minus here. This is a single stage process, and if we include a plus here, this is a 3-stage process, okay? So in the 3-stage process case, the conditions is the following, and then the second stage was the following, and when you create the new black oil table and you click when you click save on this button, properties for this 3-stage process will be generated, okay? But just for simplicity right here, I'll just discard it. But for this surface process right here, which is the benchmark, the 2-stage, we can go into the black oil table and see what kind of formation volume factors and solution GORs do we have. The solution GOR, of course, for that surface process, that was how we generated this composition in the first place, was to input 1,000 scuffs per barrel, and the associated formation volume factor for that is calculated to be, for this surface process, 1.52. And then our job is to analyze, okay, if we add a stage or we remove a stage, how much will these 2 properties here change? And we have also learned in the small presentation earlier today that viscosity should not change. So you can also look at that to make sure that that does not change. And that is the entire exercise. Just write down those three numbers, convince yourself that actually these properties are a function of the surface process, and you've actually learned or at least emphasized something very, very important from a PVT perspective, and especially when dealing with black oil tables.